Hello friends, today we are going to discuss a Putnam problem which was asked in 1938, and this question was in two parts and present in section A, question number 5. This question had two parts and both the parts were the part of limit chapter, and the first part which we are going to discuss first and then the second part. The first part said find limit of x square by e raised to the power x where x tends to infinity. And in the second part we had to find the limit of this integral divided by k where k tends to 0. So before starting the solution of both the parts, please subscribe to my channel for more such videos and like the video if you like the solution. Let's start the solution. In the first question, because x is tending to infinity and we all know that x square will also tend to infinity, and e raised to the power x and x is tending to infinity, therefore e raised to the power x must also tend to infinity. Thus we can say that it is infinity by infinity indeterminate form, because we have 7 indeterminates form. Oh, and it is one of them which is infinity by infinity. So without any problem, we can use L'Hospital's rule where we differentiate the numerator and denominator. So this, let's call this limit as L1. So L1 can be written as limit x tends to infinity, and the derivative of the numerator will be 2x and the derivative of the denominator will be e raised to the power x. Once again, if I substitute x, then numerator is still tending to infinity, denominator is also still tending to infinity. So we will apply L'Hospital's rule once again. So let's differentiate x tends to infinity 2 by e to the power x. Here, if you observe that if I substitute infinity here, then numerator is constant but denominator is tending to infinity, which we can understand like in the denominator it is a very large number and the numerator it is a constant, so the overall number must tend to 0, so the limits value will be 0, which is our answer for the first part. Okay, now let's solve for the second part. Second part is involving an integral which is running over 0 to k, and the function is 1 plus sine 2x whole raised to power 1 by x. Now since k is tending to 0, that means we can say that this variable is tending to 0 and the limits are tending to be same, because it is also 0 and it is tending to be 0, the limits are tending to be same. Therefore we can say the value of this whole integral will be tending to 0, and since k is tending to 0, so denominator will also tend to 0. So I can say that it is 0 by 0 form of all the 7 determinant forms we know. So once again I will use here L'Hospital's rule. So let's rewrite the equation after using the L'Hospital's rule expression. If I use L'Hospital's rule over here, then we can clearly use differentiation of integral over variables. Then I will substitute when I am going to differentiate it. So I will substitute, because I am differentiating with respect to k. One more point to observe that or note that I am going to differentiate with respect to k because k is tending to 0. So let's differentiate with respect to k. Because we are differentiating this integral, we will get k will be substituted in the places of x of this function 1 plus sine 2k whole raised to the power 1k multiplied by differential coefficient of k, which is 1, divided by derivative of k, which is also 1. Now let's rewrite once again. K tends to 0. This is 1 plus sine 2x, sorry, k, and this is 1 by k. Okay. Now if I observe k is tending to 0, therefore this must tend to 0 and this whole part must tend to 1, and this part is tending to infinity, so it is our 1 raised to power infinity form. The main thing while solving the limits is to identify the form of indeterminate which it is taking. It will help us a lot, which we are obviously seeing here. First of all, we identify infinity by infinity, then 0 by 0, then 1 by infinity, 1 raised by infinity. So whenever the limit is tending to 1 raised to forming 1 raised by infinity, which with what formula we use, we have already derived in our courses or in studies. I am rewriting here. If limit x tending to a f of a whole raised to power sorry x and gx is such that f of a is tending to 1, or better say f of a is equals to 1 and g of a is tending to infinity, then its limit is equals to e raised to power limit x tends to a and fx minus 1 times gx. Okay, this is the limit, the value of limit of this function like fx raised by gx, which I am going to use over here. So 1 plus sine 2k is f of k and 1 by k is your g of k. So let's rewrite it. E raised to the power limit x tends to 0 and 1 plus sine 2k minus 1 multiplied by g of k, that is 1 by k. Now e raised to the power limit k tends to 0 and here 1 cancel out, then sine 2k by k. Now let's multiply 2 in the denominator and in the numerator. Now we know that one more formula of limits, that is if limit x tends to 0 and sine x by x is present, then it turns out to be 1, which I am going to use over here. K is tending to 0, therefore 2k will also tend to 0, denominator is also 2k, so this whole part will turn out to be 1. So it is nothing but e raised to the power 2, or e square is the answer for this question, and here the answer was 0. So this is my solution for the Putnam problem of 1938. It had two parts, which just about how you observe the limits and how you apply the formula for different cases of indeterminates. So I hope you enjoyed the solution and also like the solution. Thanks for watching.